2 less than 10. We've done this, but I'm doing it again. There are a few people who are in class. So it says here, if you had a meteoroid and an asteroid start a race, and they both start at the starting line, is this asteroid slower or faster than the meteoroid? So one thing you can do, and I know there are no numbers, is, well, create a number. So let's say, I don't know, 1, 2, 3, let's call it minutes. And you don't have to do this, but it's nice if you have some context. And then let's say the distance, I don't know, 10 miles, 20 miles, 30 miles, etc. So let's get a few points. So after 1 minute, the asteroid, okay, actually, let's pick, let's not pick 1 minute, let's pick 2 minutes. 2 minutes, the asteroid is 10 miles away from the starting line. At 2 minutes, the meteoroid is, if you look here, right, point 230, 2 minutes is 30 miles away from the starting line, and at 2 minutes, the asteroid is at 10 miles away from the starting line. So you can do this, right? Put some context, put some numbers. It's easier to visualize. So you can clearly say that the asteroid is slower than the meteoroid. How do you spell meteoroid? Meteoroid. Okay. Because it covers less distance in the same amount of time. Right? And that's key here, the same amount of time. So you want to pick a time frame. So again, I picked 2. Right? I just made it up. So at 2 minutes, right? Look where the asteroid is. It's at 10 miles away, and at 2 minutes, the meteoroid's at 30 miles away. So you could have picked other ones. So let's say you want to pick 6 minutes. So this is 5. Here's where the asteroid is. And the meteoroid, well, you would have to extend this line, right? You would have to extend this line. And you can clearly see that the meteoroid would be even further away. Okay? And that's the answer for that question. So, again, it helps if you put some context. This is talking about, International Space Station requires life support and crew supplies. The graph shows a relationship between the cost of life support and crew supplies as the number of days spent in space. Which costs less, life support or crew space? So, again, I'm going to make some intervals here: 1, 2, 3 days, 4 days, 5 days, etc. So after 1 day, and again, let's make that $100. So after 1 day, let me just make that a little better. After 1 day, it's right here. The life support cost you $100. Meanwhile, the crew supplies cost you $200 after 1 day. That's how much it's their expenses. After 3 days, look, after 3 days, life support would be $200. And then the crew supplies, after 3 days, it would be, I don't know, 300, 400, 500, 600 bucks. So again, you can very clearly, and again, you put these numbers to put some context, right? It's easy for you to visualize. You could have put other values. It doesn't matter. And if we were to compare, we can say which one is cheaper. Which cost was it? The life support costs less. Than the crew supplies. For the same amount of days. Now, if you look at the line itself, you could, by now, after the second example, you can see that the less steep the line is, right? In this case, the less money it was spent. So, out of these two, which one is the less steeper line? Is the green line here, right? So again, by that I mean, hey, just compare this line and this line. Which one's the less steeper one? This one. Okay. So the one that it's steeper, it increases faster, it goes faster, or it spends more in this case, right? As opposed to the one that's less steep. Okay, so you can also use the line, right? And notice the steepness of the line. Yeah, that's it for that one. This one, you have one piece of information. I'm not a big fan of this. So we had ounces of honey, so let's call this ounces. On the x-axis, we call that ounces. So that, and this will be my x. And here will be my cost. This will be my y-axis. So let's create a table. So we can call ounces, which represent my x-axis, my cost, which represents my y-axis. Let's get some numbers in there. So the only relationship that I have comes from this statement right here. So if you have 12 ounces, if you go to the supermarket and say, hey, I'd like to buy 12 ounces of honey, you're going to pay $5.40. So from that, so just from that little piece of information, I can find my constant proportionality. So you would go 540 divided by 12, right? And you would get that constant proportionality is 0.40, it's 45 cents. So times 45 cents, times 45 cents, times 45 cents. And we can create a few more points here. So we definitely want the 1, right? Because that represents my unit rate. So for 1 ounce, so if I went to the supermarket and said, I want 1 ounce of honey, I would pay 45 cents. Okay. Let's create a couple more. Just because I want a few more points. Let's say I had 2 ounces of honey. I would pay 90 cents. So let's use this information and create a graph. Now, if I went to the supermarket and bought 0 ounces of honey, I would pay $0. 1 ounce of honey, it's going to be 45 cents. So you notice that half is 50 cents, so a little bit under that. And again, I'm going to use your best judgment here. For 2 ounces is 90 cents, which is right under $1. And that's definitely more than enough for me to create a line. Remember, you only need 2 points to create a line. I want to stretch that out. Does it make sense here for me to connect the dots? Yeah, because what if I wanted 1.5 ounces? Would I be able to? Let me just go like this. So all these points, right, on the line make sense. Is it possible to buy 4.1 ounces, 5.2 ounces? It is. So all those points represent different order pairs that represent different quantities, different ounces of honey and its respective prices. So how much does the honey cost per ounce? And that's right here, our unit rate. Honey per ounce. So the honey per ounce is for every ounce of honey, I pay 45 cents. I'm going to skip this first. Well, actually, let me do it. But what if it was the other way around? Instead of me going to the supermarket and say, hey, give me 2 ounces, 3 ounces, I said, here's $1. So let me put $1 here. Give me however much ounces of honey I can get out of that. So for $1, well, think about it. We're going backwards. So going from ounces to the cost, right? So if I had the ounces, I would just multiply by 45 cents. But if I had the dollar and I want to go backward, I'm going to divide this dollar by 45 cents. And in class, we said that it was going to be 2.22222222 forever. But we're going to write that as, sorry, I almost fell down. As a fraction. So let me just divide that. So 1 divided by 0.45, it's 2.222. And as a fraction, right, as a fraction, which is even better, I'm going to say, hey, you can take 2 2/9 of an ounce. That's how much honey you get. So how much can I buy for $1? So for $1, right, which is the other unit rate, right? So here's the second unit rate. So for every $1, write that for every $1. So we're going for every $1, I get 2 2/9 of an ounce of honey. So we have two unit rates. One is per ounce, and the other one is per dollar. So now they want two equations. Well, remember, equation of proportional relationship comes in this format. So if I wanted to find y, which is represented by the cost, so think about this. If I want to find the cost, and I'll change the y to a c. So if I wanted to find the cost, right, what do I have to do? Well, to find the cost, how much am I going to pay at the register? I would take 0.45 and multiply it by the ounces of honey. Or in this case, they said instead of using x, we're going to use h. So if I want to find the cost, I take 0.45 and multiply it by however much honey you want to buy. 1 ounce, 2 ounces, 2.3 ounces, etc. But then they said write another equation. Well, let's go the other way. Just like I had two different unit rates. What if I wanted to find how much money can I take? Wait, sorry, how much honey can I take? Yeah. Well, remember, if I went backwards to find the amount of honey, what do we do here? So let's look at this line. I took the dollar, which in this case is the cost, and I divided that by 0.45. So here are my two equations. So one helps you find the cost, and the other one helps you find how much honey you take. 6 we already did. To choose one of the equations. Obviously we chose this one, and we graphed it. So this line has a name, the name of this. So this line is called y equals, or c, 0.45x. Okay. Let's go to the other page. What is this? Is this relationship proportional? Yes. Let me clear the page. Yes. It goes through the origin. And it's a straight line. Okay. What is the constant proportionality? Well, to find a constant proportionality, I want to create a table, or you can get a point, right? So again, I know I'm asking you to do a little bit extra, but here's x and here's y. My x-axis represents the time. And my y-axis represents, what is this, number of pages. So let's get a point, and then let me show you a point you shouldn't choose, this one. Why? Because I don't know what that value is. What is that, 45, 44, 46? So I don't know its precise coordinate. So you want to take points that are like this one. It's on the intersection. That one I can tell you what it is exactly. 30 minutes, he reads 15 pages. That's the point. I want to pick a different point. Pick this one. What is that? 70 minutes, he reads 35 pages. And again, it doesn't matter which one you picked. Well, I picked those two. And I'm going to use that information. 30 minutes, read 15 pages. 70 minutes, I read 35 pages. And so forth. And you can fill this table with as many ordered pairs as you can find, right? You can actually look, we have so many. You can use this one, you can use this one. So let me plug in a couple more. 10 minutes, I read 5 pages. There's another one here. 20 minutes, I read 10 pages. And so forth and so forth. Okay. Now, can you find a constant proportionality? Yeah. K, and you pick any of these order pair, 20 and 10, 10 and 5, 7, 35, 30, 50. Pick one of them. Let's pick the easy one. Let's pick 5 and 10. So we divide 5 divided by 10. And we get that the constant proportionality is a half, or if you wrote it as a decimal, 0.5. So I can go back here and just fill it in. Times a half, times a half, times a half, times a half. So let's write the equation. So here says what's the constant proportionality is a half, 0.5. Okay, let's get the equation. What is the equation? Well, to get the total number, if I want to know how many pages you read or you're going to read, I need to know how much time. So to find the number of pages that I'm going to read, right, it's going to be half, or 0.5, times multiplied by the number of minutes. So this is going to help us answer question 9. I'm just going to go back here, and I'm going to tell you what each of these 3 pieces represent. The y represents the number of pages, right? Because that's what's on the y-axis. Remember the y-axis. The x represents the time spent reading. Time spent reading in minutes. And then what is the half? Well, it's half or 0.5, however you want it. This is number of pages that Joel reads, the number of pages read in a minute. It's our unit rate, right? So this is my unit rate. So again, this is my unit rate. And it's also a constant proportionality. So he reads, so again, if I went over here and put the 1, right, so let me add the 1. If I give him 1 minute, we give Joel 1 minute, how many pages would he read? He would read half a page. That's my unit rate. So my unit rate in the table, my unit rate here in my equation, and then here I'm going to come and put a 1 here. And this would be half a page. And on the graph, here's my unit rate. The unit rate is 1 minute, he reads half a page, right? So the x, remember this is the x and this is the y, so the x coordinate represents the number of minutes and the y coordinate represents the number of pages. So that's exactly what question 9 is. Okay. All right. No weird questions today. 10, write an equation. Okay, we did that. Okay. Question 11. Match each equation with its graph. So y equals 1/4 x, y equals blah, blah, blah. So they're all proportional. They all start from the origin. Let's try to cheat over here. They're all proportional. So now we got a match. So let's go to graph A. Let's go to graph A. And since they're all proportional, let me create a table for graph A. What does it say? My x and my y. So you can pick this point, you can pick this point, pick whatever point you want. So we're going to take this point. And lucky for us, that's the unit rate right here. Because it's 1 and then, so if I take a 1 and then what's my y value? Why did I do that? 1, 2, 3. And it looks like 1 1/3. So that looks like 1 1/3. Right, so now what does that tell me in a table format? Well, in the table format, it means that when x is 1, so when I have 1 of x, for every 1x, I get 1 1/3 y. So what was my constant proportionality? What did we multiply by? Times 1 1/3. So that's our constant proportionality, right? So the equation for this, so if I were to ask you, let's write an equation for that. You would get, hey, to get y, I would take 1 1/3 and multiply it by x. So, but notice that none of these numbers are in mixed numbers. So let's change 1 1/3 to an improper fraction. Times and plus. 3 times 1 is 3, plus 1 is 4, so it's 4/3. So do we have anything that has a k as 4/3? We have it right here. Right, so let me write y equals 1 1/3 x. Same. Right? We actually rather write it as 4/3. So that's done. Graph B. So notice that with 1 point we can find everything. So this one also has a unit rate. So all these 4 actually automatically give us a unit rate. So listen, for every 1 that I have of x, how many y's do I get? What is that? 1, 2, 3, 4. That looks like a 1/4. So for every 1, I get 1/4 of y. So if I were to create a table, this is my x and this is my y. So that translated to a table becomes this. If I have 1x, I get 1/4 of y. What's my constant proportionality? Well, times 1/4, right? So to write the equation for this, y equals the constant proportionality, 1/4 times x. And B is this guy. For letters, sorry, graph C. What's the equation? Well, again, let's take advantage that they give us this. Look, for every one x, every time I have one x, how many y's do I get? I get 2 y's, right? Let's graph that as a table, x and y. So every time I have one x, I get 2y. So if you want to find a constant proportionality, this one's easy. It's just times 2. So there's our constant proportionality. So let's write the equation for this. Well, to find out y, I want to know the y value. I'm going to ask me to take the 2 and multiply it by every x value. So y equals 2x, and that one's easy. It's right under. And the last one, I know, and you know that it's this, but I'm going to do it anyway. So take a point, and again, they're giving us a unit rate, right? The 1, right? So but if you could also pick any point in the line, you get the same answer. So for this one, let me pick that one, take advantage. So again, the x value. So every time I have one x, how many y's will I get? This is 1.5 or 1.5. 1.5. Let me create a table. X and y. So if I have one x, they're going to give me 1.5y. So what's my constant proportionality? Well, times 1.5. So if I had 4, it would be times 1.5, and that gives me 6. If I had 10, if I had 10x, that would be times 1.5, would give me 15, etc. So where's my unit rate? My unit rate's here. Let me write it. For every 1x, I get 1.5y. But you're going to say there is no 1.5. None of them look like 1.5. So again, 1.5 is the same thing as 3 over 2, and which makes graph D number 12. Okay. And that's that. Wow.